Hi everyone, welcome back to the channel Techie Book. Today we are going to discuss about recursion. If recursion feels confusing or scary, don't worry. In this video, I will explain recursion in the simplest possible way. First, we will start by understanding what recursion really is. Then, we will solve problems like printing numbers, Fibonacci using recursion tree. And finally, the most important concept, pick and non-pick to generate all subset for a string or arrays. By the end of the video, recursion will finally make sense to you. Let's start. Okay, let's see what recursion is. Recursion is a technique where a function calls itself to solve a smaller part of the same problem until a base case is reached. To say in simple, a function which is calling same function again and again, which is called recursion. Now let's start with the practical example. I have a function here. So this is called by this function. And this is called from main method. You can say this function is calling this function and it will go inside of this method and this function will be called, this will go on call to this one, and this is going to be called this one, and this is going to be called this one. So like this it will keep on do like this. There is no ending. It is a never ending process. If you consider how these methods will be added into the stack. Now, whatever the function which is calling from main will be first added here. Before that, the main method will be added here. Then, this is going to call this function. Like this, it will keep on grow. It's a never-ending process. The stack will keep on grow like this. It will reach the maximum limit of the stack. Then we'll get stack overflow. This is actually called recursion. We have to stop this one. It will not. It should not go like this. We will see one example here. I have a function which is calling by 1 as an argument. Okay. And here again I'll be calling 1. This is going to call this one. It's a method call. And this function will be going to call this again. So I need to stop this. How I can stop this? We have to write a condition that going to be stop this method call. How we can do that? I can write if 1. If it is a 1, go inside of this one here, and then here I can do return. What return will do, it will not allow to go to call this method and it will be stopped here. The stack will be become like this, f of 1. Then nothing will be called. It is going to be returned to the main. Going to be returned to the main, and main will be closed and function is already closed. Our main target is to print numbers from 1 to 5 or 5 to 1. How can we do that? And here again, let's pass 5. And if 5 return. So the stack will be go like this. And the next cell I want to place here. I want to insert 4 here. How we can do that? What I can do? This is the function which is going to be come here. So what I have to do, instead of stopping at 5 here, let's stop at 1. Wait until it reaches to 1. How can it reach us to 1? I have to subtract 1 from the 5. Then 1 by 1 it will go to 5 to 4, 5 to 4, 4 to 3, 3 to 1, like that. The stack will be like this: 5, 4, 3, 2, and 1. Instead I'll go with 0. I want to print 1 as well and show 1 as well. So this is how the stack will be generated. Suppose I have a function like this, function of 5, and then if 1 return, and then we are calling function of 5 minus 1. Now I want to print the data. How can you print the data? So there is a two conditions. I can call SOP before calling that method. Suppose I have stack like this. Before, suppose main function is called this one with the 5. Before calling this one, I want to print SOP of 5. Then I'm going to call f of 4. Then SOP of 4. Then I'm going to call f of 3 like that. Then it will go to f of 2, f of 1 and f of 0 and it will be written here. First I will be printing 5, then I'm calling method 4. After that I'm going to print 4, then 3, then 2, 1 like that will be printing. This is my output. Okay, this is my descending order. I want to print the data into the ascending order. What I can do? What will happen if I keep SOP after the method call? I have a function called by main method. After that, I am going to print SOP. Then f of 4. A print SOP will not be called. Sorry. Then f of 3. Then f of 2. Then f of 1. For example, let's say I have a function here which is 5. I'm going to call function of 4 from here, and this is going to call function of 4. This is going to call function of 3. This is going to call f3 like this. So the SOP will be after the method call. If you see here, the SOP will be after the method call. Now f of 3 or f of 2, f of 1 is completed. Once this is over, the SOP will be printed. What is the value will be here? 3. And here it will come here. The value of the n here. Suppose if I say n, the n value here is 4. SOP 4 be printed. And here SOP of 5 will be printed. It is in this order. First 1, 2, 3, 4, 5. So this will be called like this. If you go with the stack representation, this will be going to print 1. Then it will be come out of the stack. This will be print 2, come out of the stack. This will be print 3 and it will come out of the stack. Print 4, come out of the stack. Like that, all will be removed from that and it will be printed like this. Now let's see the code example for this. So yeah, we will go with the code example. Here I am going to call print number function. So as I said, if I call like this, it will give you stack overflow error. Stack overflow is printed. Okay, now let's go with the numbers. Let's assign the number into number equal to 5. I'm passing number here. And I'm going to take that number here. Here I'm just calling here. Definitely we're going to get stack overflow. I want to stop this stack overflow. Now after that, what is our goal? To print 1 to 5 or 5 to 1. I have passed 5 here. I want to print 1 to 5 or 5 to 1. What I can do here? Instead of stopping at 5 here, let's stop at 1. Because if I pass 5 here, we need to call this method for 4 5 times. 5 to 4, 4 to 3, like that till 1. So 1 also to be printed. Let's keep 0 here. Then only it will return. Instead of number here, we print number minus 1 as we discussed earlier. Subtract the 1 from the number. Now let's see by adding SOP here with this number. We are going to print 5, 4, 3, 2, 1 in descending order. Why? Because this is called before that method. If you go to the debug, the 5 will be printed. Might see that 5 will be printed. Now the function will be called with the 4. If I go here, the function will be called with the 4 and 4 is printed. Now see, number will be the 4. That 4 will be printed here. Then 3, 2, 1, 0. After that, it will come out of that method. Nothing will be there after that. That's it. Suppose I want to print numbers after the method call. So what will happen? Now see, it is printing the numbers into the ascending order. If we go to the debug mode, number 5 will be called, then number 4 will be called. It will not come to this print statement. See, number 3 will be called, 2 will be called, 1 will be called. So then now stack is filled with 1 to 5 methods. Then it has to come out of that method. Now it will come out of that method. What is the number here? 5, 4, 3, 2, 1. This is the last number into the stack. So once it is coming out, it will print 1. We see here, it is printing 1 and it is removing. And then it is printing 2, after that it is removing, and printing 3, after that it is removing, printing 4, it is removing, like that it will be happening. Don't confuse with this number. This will be the number of calls. Suppose method 1 will be called, method 2 will be called, method 3 will be called, method 4 will be called, 5 will be called, like that. Then method 5 will be removed, 3 will be removed, 2 will be removed, 1, like that it will be removed. This is not the method arguments what we are passing. This is the method number that which we are calling. Now let's see the tree visualization, how it will happen. For that we will take an example of Fibonacci. What is Fibonacci? The previous two elements. If we add the previous two elements, 0, 1, suppose if we add these previous two elements, the output will be the next element. If we add these two elements, that output will be the next element. If we add these two, and output will be the next element, like that. So what is this? 0, 1, 2, 3, 4, 5. The fifth value will be the 5. The fourth value will be 3. The third value will be 2. Like this, it will be there. This is called Fibonacci series. So number we can say 1, 1, 1, 2, 3, 5, 8, 13. It will go like this. This is Fibonacci numbers. So everybody might have know about this, what is Fibonacci series, the number wise. So now we can clearly see here this one and this one. These two, if we add, we will get this value. And if you add these two, we will get this value. Suppose if we add 0 plus 1, we will get 1. If we get 1 plus 1, we will get 2. If we add 1 plus 2, we will get 3. Like that. We need to get this value first. Then we have to get this value and we have to add both of them. Then we will get result of this one. And again that result will be added here and will be added function here. Then we'll get output. I need to have a one function. It should be return 0. I have one more function. It should return 1. If we add both of them, output will be 1. So how we can do this one using recursion? I have a main method. I am calling one function here. Function of 5. We'll go here. Function of 5. What I need to do? I need to get previous two elements. So suppose I have 0, 1, 1, 2, 3, 5. I want to get this element. This is suppose I can consider as n. I want to get this element. For example, you can take, I want to get this element. This is, I consider n. How we get this value, that is 2 minus 1. 2 minus 1 will get 1. And this value 2 minus 2. 2 minus 2 will get 0. What will, but how can we say that? Suppose if I take a n minus 1 equal to 1, n minus 2 equal to 0. If you consider like this, n minus 2 plus n minus equal to n. This is the output we are going to get if we add this. So what I have to do here, f of 5 minus 1 plus f of 5 minus 2. We have to return this. If I return this, it will come here and it will be called with the 4 first, then it will be called with the 3. So this is how it will be created. So what will be the base case here? Base case is these are the elements. If I reach to this point, I don't need to go further like minus 1, minus 2. I don't need to go further. So what I have to do, if 1 or if 0, return. Okay, now we will see tree visualization. Suppose consider I have a 5. This side it will be 4 and this side it will be 3. This is n minus 1. This is n minus 2. And we have to add these two. And we'll come here. This will be 3 and this will be 2. If we come here, this will be 2. This will be 1. If we go here, it will be 1 and it will be written. After 1, there is nothing to go. This will be 0. And if it is left side, there is n minus 1. 1. And it will be 0. 2, comma 0. 2, comma 1. 1, comma 0. So we are going to add these two. Going to add these two. And yeah, here, 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 here. 1 plus 0, we will get 1. And here, the value already is 1. We will get 2 here. The value of 2, 1 plus 0, 1. The value of 4, 3. Here, value of 2, 2. Sorry, 1. 1 plus 0, 1. Here it is 1. Then it will be 2. Then it will come here as a 5. So this is how the tree visualization will be look like. Then how this data will be stored into that stack. Suppose I have a stack here. I have added 5, 4, 3, 2, 1. 1 will be written back. Okay, we'll go to 0 as well to be written. If we come here, 1 will be, 0 will be, before 0, if you come to here, 1 will be written and 2 will go to 0. 0 will be over and 2 will be over. Now it will come to 3. 3 to 1. 1 will be written, 3 will be written back and it will go to 4. The fourth value will be 2 and 1. 1 will be written. Then 2 will be called 0. 0 will be written, 2 will be written. 4 will be over. And we come to 5. 5 will be called 3, 2, 1. 1 will be written. Then 2 will be called 0. 0 is over. Then 2 also be over. Then 3 will be called 1. 1 will be gone. 3 will be gone. 5 will be gone. So like this, the stack will be stored into that memory. This is how the tree visualization of this one and that the actual data will be stored into the stack will be like this. Now we'll go with the code example. So I have already made method. So I'm going to write Fibonacci. Now what we'll do, we have to call Fibonacci number with I minus 1 plus Fibonacci of I and 1. If it is a 1 or lesser than 1, it will return. What should be written? I. Why I? We come here. This is the value, is the number. This is the number. Whatever I pass the number, that number will be here. I have to pass, return this number and this number. That's what I will. When it's the base case, I have to return 1. When it comes to that here, I have to return this 2. Like that. See, the value will be 8. See, 1, 0, 1, 2, 3, 4, 5, 6. Value will be 8. I want to go and print 5. The value will be 5. So this is one, just want to show how the stack visualization works, how tree visualization is works. It's not completely in detail of recursion. It's just a simple way of telling what is recursion and how stack and tree visualization will look like. Then only we can able to do the problem of pick and non-pick using printed subsets. I hope you will be clear with this Fibonacci series and how tree visualization will work.